Hello. Um, this is Tor. I'm currently the vice president, vice president of the Game Builders Club, and this is just a really basic um, intro into how Unity works. Um, so the first thing you might be interested in is how do I download Unity? Well, it's pretty simple. Google Unity Hub download, and it's the first one. Um, If you're watching this in the way future, thank you for coming back to this video of all things. Please find a more up-to-date resource. But if you're watching this in 2021, early 2022, you should be fine. Um, and then you hit download Unity Hub from there, and then it'll guide you through the download process. Um, I'm not really going to focus on the downloading process, but once you um, finish installing all of that, you'll be taken to a screen that looks something like this. You might be prompted to sign in with an account. You can use a Google account, as I've currently done. Please ignore my dead name. And I don't think you're required to make an account, but it's going to nag you until you do. But this is what Unity Hub basically looks like as soon as you download it. You might be thinking, oh, well, why didn't I just download the install itself? Like, why didn't I just get Unity? Why do I have to download the hub? Because it's easy and it works better this way. Because it automatically goes and finds what's the most up-to-date install and lets you know when you're getting dangerously out of date. And also it can help like automatically update your new projects and stuff, and it helps keep track of where all your Unity projects are, and that's really helpful. So we use the Unity Hub and we don't question it. If it bugs you about a license, go to settings up here with the little gear, license management, and it should let you activate a new license. Just get the free one, because unless you're making a couple hundred a year off of games you're making with Unity, you don't have to worry about that for a while. Yeah. And then if you first download this, it's probably not going to have projects already found. You already have like an old Unity project, you can hit the add button and go find it. Or, like a lot of you who are very new to Unity are going to have to do, you're going to hit the new button. And it might say, oh, you need to go get an install. You go to here to installs and you hit add, and it'll recommend what version of Unity you should get. You hit new, and you hit what version of Unity you would like to use. I would like to use 2D Unity because that's what I personally use. A lot of the stuff I'm going to go over in this, pardon me, is still applicable to 3D. And then once you've made a new project, you type in the new name and you can choose where to save it and stuff like that. And you hit create, and it'll close out the hub and open up your new project. I have already opened up my project, if I can find it. Okay, here's the old tutorial that I had in the spring. And you can see it's got a lot of stuff currently going on. And this is a project that I've been working on for a couple hours. Had been working on for a couple hours. So it already has a lot more stuff going on. I'm choosing this because it can help you see how things will look once you have more things in your game. Because if I say, oh, here's the scene view where all of your stuff in your game is, and it's blank, well, that's a little disappointing. But yeah, this is the scene view, and it's going to show you where everything is currently located in your game, whether it's currently visible or not. So I can choose to like make this coin invisible. And it'll help kind of show you how things are going to be laid out. If you want to see exactly what's going to happen when you run your game, you can click this game tab and it'll show you any UI that you have set up. It'll show you where everything exactly is, which is all nice. But one thing that might happen is you might have invisible objects in your game, and you might say, oh, well, I want to know where my zone of death is. That's what the hierarchy comes in. So it can help you see what items are grouped together. So I have all of my coins grouped together, and you might have seen that they all lit up when I clicked on that. Wow. And then I can click on individual objects to see where they are. Um, I can click on invisible objects to see where they are. Yeah. Um, why do I have 3 zones of death? Anyway, um, so once you can find things here, and if you click on an item either in the scene view or over here in the hierarchy, you will see that information will pop up over here. Every item in the game, regardless of what it is, if it's listed in the hierarchy, it has a transform. A transform's just information about where is it in 3D space, even in 2D games. We're in 3D space. Um, so it'll show you where the item is, how it's rotated, how big it currently is. Every item is going to have a transform. If it is visible, it'll have a sprite render, which is basically just what pictures it's currently using. So, like for the player, it's currently using a picture named Idle Zero for to represent the player. Um, it's got a couple of other items, but the big one that I want to highlight is that if the object that you're currently using has physics on it, you need a rigid body. What's a rigid body? Go watch my last video a couple months ago about what a rigid body is. But basically, it helps keep track of how physics are currently being applied to the object. So you can see that the player has a rigid body, which means the laws of physics apply to the player. And then from there, I can use my own custom script, like this platformer movement script, in order to specifically define how the player is going to behave. Down here are the assets. So it'll look like this, and you can sort everything that exists in your game. So if you're like importing pictures to use as backgrounds and stuff, that's going to be down here in the assets. Any scripts that you're using are going to show up in your assets. Pictures that you're using, anything like that. These are sprite sheets for the player. So that's assets. It also has a console. So if you're using like outputs and stuff to keep track of whether or not you're of like whether or not things are working, you can use the console to keep track of that. Yeah, and then if you want to test your game and see whether or not it's currently working, you hit the play button up here, and it'll take you to your game view, and you can see how your game is currently working. Any UI that you currently have going on will show up. Any scripts you have going on will work. Any animations will play, and this is how you test your game. Any changes that you make while testing your game will automatically be reverted. So you can see, like, I can pick up the coin, and then I stop the test, and the coin comes back. That's intentional, and it's because like if I deleted the coins in my test and then they didn't come back, that would be frustrating to have to reinsert all the coins after every test. But that also means that any changes that you make to your game while testing will not remain after you stop the test. So keep that in mind if you've got like public variables that you're messing with. Write down whatever values you change them to while testing. Otherwise, you're going to be really kicking yourself later. So that's my little description of what a basic 2D Unity game looks like once it's a little bit more polished. Now I'll show you what you're probably going to be starting out with. This is a yep. Okay, so this is what a Unity game will look like once you first start it up. And you can see it's a lot more empty than what I had previously. To get started making a game, you're probably going to want a sprite for the player. So to do that, you're either going to right click in the hierarchy, or you can click Game Object, go to 2D Object, Sprites, and then pick whatever shape you want. I'm going to go with a square. I'm going to name it player. Currently, no laws of physics apply to the player. So to do that, make physics apply. I'm going to type in rigid body 2D. And wow, now we have a rigid body. Don't worry about why that works. Or, what's going on with that. But it does. Basically, now we've got a rigid body, which means now the player is affected by gravity. Which is good, because it also means that any physics that I apply. To make a new script, you can type in new script. And then I want to make the player move around as if we're in top-down movement. In this top-down player movement. Please be descriptive when naming things in your game, because you might think, wouldn't it be really funny if I named every single item in my game E? And then you have over 1,000 objects in your game and stuff, and everything is named E. You're losing things. And I was really dumb in sophomore year of high school. Anyway, this is Visual Studio. When you were downloading Unity, it probably prompted you, do you want to download Visual Studio? I can recommend using it for Unity, but you can use any editor as long as it can save files as a CS file, which stands for C#, or you can use JavaScript for programming. I like Visual Studio, and I prefer C# over JavaScript, so I will be using those. If you prefer one or both of those other options, you can do so, but you will also have to ask someone who knows what those are for help. I'm just going to go ahead and add in a really basic movement script, and then I'm going to describe what exactly is going on with it, because I've tried going through and typing through the whole, describing what's going on with the script, and that takes a long time, and I don't want to waste people's time. You might see that some of it looks pretty similar to Java or C++ or other languages like that. We've got import statements. We have the name of our script. A vector 2. So Unity recognizes that if you're working in 2D or if you're working in 3D, you're probably going to have to be keeping track of things in X and Y. So a vector 2 keeps track of X and Y. A vector 3 keeps track of X, Y, Z. You can use that to store vector, speed vectors. You can use it, I guess a speed vector is a little bit of a misnomer because it has direction. But you can keep track of velocity vectors and position vectors. Does that make sense? Anyway, you can use it to keep track of two numbers at once, which is helpful a lot in math with games, I think. So to make a new vector, you type in something basically like this. I made it public. The difference between public and private, everything is by default private, I think. Um, wait, wrong one. So over here on the player, you can see that I can see the speed. That's because I made the variable public. Making it public basically just means, hey, I can type in what the thing is. Um, I could also drag in other items. So if I made like a public spot that I want to go to when I respawn, that's what it does. So that way I can reuse this and respawn in a bunch of different places and different levels and things. That's the difference between public and private. So these three don't show up, but this one does. Um, Unity has a method that it will call once per frame, and that's called update. And that is really useful if you want to have the player move and do things, because generally you don't want a thing to only happen once at the very, very start of your game and then never happen again. That's a little bit of a boring game if it only has one frame of doing things. So update is called once per frame, and you can use it to mess with properties of things such as transforms. But again, it's called once per frame, which means if it's taking a long time to execute, that might be a problem. So to fix that, like if it's taking a long time to execute, it'll slow down the number of frames you're having a second in order to compensate for the fact that it's slow. Like it simply won't be able to complete the update that many times, and basically it's a problem and your game can get really laggy. So to fix that, they made fixed update. And fixed update can run as few as 0 times a frame, or it can run a bunch of times per frame. And because it can slow down and keep track of things, it can slow down and do more difficult things. I use it for physics stuff. You technically don't have to, but that's what I do. Okay? So I use update to keep track of like user inputs and basic function calls and stuff. And then I have fixed update do all the physics stuff. So user inputs. Unity has user inputs. Okay, so if I go to edit project settings, I can look and see what our inputs are. When you load in, it might look like this. Click the drop down, and it'll show you every different name that it has for things. So, horizontal input, that's like a name that exists, and then I can designate what buttons mess with horizontal axis. So, left goes left, and right goes right, because it's an axis, you know. Fire 1 is mouse 0 by default, I think. So this is how you mess with user inputs. So if you wanted to have a potato that has like a sensor in it, and when you slap the potato, it makes your player jump. I don't know why you would do that, but that's how you would set that up in the input manager. Back to our script. So to mess with the inputs, you make a call to that input manager, and you can make call for different like you can call to check on different things, like is the button fire one currently pushed? Yes or no. And if it is, then it'll do a thing. Or is the axis of horizontal currently left of zero or left? Or is it beneath zero, down? And it goes through. I currently have the script go through and keep track of the different directions that I could be trying to move. And then I have a bunch of other vectors. One of them is the target position, which is where the player just said for me to go. Relative position is where the player currently is relative to that. And then movement is what do I got to do to get there? I apologize for those weird sounds. I don't know what they are. So target position is if I click on the screen. So if I click, that's fire one. It's going to look at where the mouse currently is pointing at. The camera is going to keep track of that and say, oh, well, they just clicked on the upper right hand corner. Which means they probably want to go there. So the camera is keeping track of where the mouse currently is at the time that you just clicked that, and it's storing that in target position. Or for these, it's storing the coordinate of target position as where the player currently is minus the speed that the distance that I go in one frame. The formula for distance, as many of you hopefully know from physics, is speed times time. So speed times time is distance, 60. I put that in there at some point in time, and I don't remember why I did that, which is fine. But basically, it's 60. It's 60 frames a second, so we multiply it by 60. And that's going to keep track of where the player is currently telling us to go. So subtract where we are by that distance, that's our target position. And it goes through and does that for all the different directions. And then it's going to store our relative position as a vector 2 as well. Where we are minus where we want to be minus where we are for both directions. And that's nice. And then now that we have a relative position, we can go through and figure out how we need to move to get there. And there are two things we could currently have when we're trying to move someplace. We could either be more than one frame away from where we want to go, or we could be less than one frame from where we want to go. So for that, we need to have like another if statement switching back and forth between, hey, this is where I want to go. Now, am I about to overshoot where I'm going to go, or am I fine to keep on going? So if I'm going to overshoot, if the distance that I would go is greater than the distance that I need to go, then just go to where we want to go. Don't keep moving. Otherwise, we're going to set otherwise we're going to move speed times the direction of where we're currently going. So either just go to the place where we need to go because we're going to overshoot it, or keep on trucking for both directions. And then the last thing we're going to do, we're going to call that rigid body because that keeps track of our physics. We're going to set the velocity that the player is currently moving by the movement. And save that. And that is our C# script already done. If you want that script, it should be available in the resources channel of our Discord, so you don't have to go through and type it all out. Um, and then we go to our player and make sure that we have that script actually on it, because if it isn't, then that could be an issue. It's happened to be a couple of times where I've written a script and then forgotten to actually put it on the item that I wanted it on. And then I got confused about why things weren't happening. So now we can see that the player can move around. Wow. Its transform is messing up. Or it's, you know, doing things. I think the player's actually falling a little bit. Okay, that's actually really cool, I think. Um, you can see the player is moving around um, with the arrow keys, or I can click and the player will go there. And that is the basics of Unity. That is how to download Unity, how to make a new project, how to make sure that you're starting it in the right version of Unity, and that you're not 3 or 4 years out of date like I was when I first joined the club and tried to open up some old projects. That didn't work. How to make a new project, how to make a new sprite, how to navigate Unity and understand what all this stuff is. Because I remember being very concerned when I first opened up Unity. And then how to apply physics to an object and how to make a movement script. Thank you for watching this video, and I hope you learned something.